Hi everyone, welcome to Techie World. So today I'll take you through the concept of polymorphism in Java. So let's straight away jump to the topic. What is polymorphism in Java? Polymorphism is one of the four fundamental concepts of OOPS programming. What are other three? Inheritance, abstraction, and encapsulation. I have already uploaded the video about the inheritance, abstraction, and encapsulation. If you have not gone through it, please go back to the channel and watch it again. Okay, let's get back to the polymorphism in Java. So polymorphism is a term which is basically derived from two different words, poly, which means many, and morphism, which means behavior. So basically, polymorphism means many behavior. So that's how polymorphism can be defined. Polymorphism, we can say, refers to the ability of different classes to be treated as an instance of the same class through a common interface. Okay. And if you talk about the real life example of the polymorphism in Java, then you can say the power button, right? You try to switch on and switch off from the same power button. Let us say you have a tube light in your home and you are trying to switch on and switch off, right? So you are pressing the same power button again and again. One time it is switching on and one time it is switching off. So that is the polymorphic behavior of the that switch. Okay. If you take another example in the Java, then you can take the plus operator, right? So if you say you are writing 10 plus 20, it will give you 30. But let us say you are writing techie plus world, it will give you techie world, right? So that's the polymorphic behavior of the plus operator that we have in Java. Now, there are actually two type of polymorphism in Java. One is compile time and other is runtime polymorphism. Okay, compile time polymorphism is also known as static polymorphism, and runtime polymorphism is also known as dynamic polymorphism in Java. So you can see on the screen, polymorphism had two different types. One is the static polymorphism and other is dynamic polymorphism. So let's have a look on some of the theoretical part about polymorphism in Java. Then we'll see the static and dynamic polymorphism separately, and also we'll see some of the coding where we will implement static and dynamic polymorphism in Java, and we'll see that through the coding as well. Okay, so let's see some of the theoretical part about polymorphism in Java. So the first point about polymorphism in Java is basically it is one of the four fundamental principles of the object-oriented programming. What are other three? Other three are inheritance, encapsulation, and abstraction in Java. Okay. The second point about polymorphism in Java is polymorphism is basically derived from two Greek words, poly and morph. Okay. And some people call it is derived from two different words called poly and morphism. So poly means many and morphism means behavior. And if you make it poly plus morph, morph means it is a form. Form is kind of behavior only, right? So polymorphism basically represents, or we can say polymorphism means many forms or many behavior. Okay. The third point about polymorphism in Java is basically it is a concept by which we can perform single action in a multiple way, right? The fourth point about polymorphism in Java is polymorphism allows us to define one interface and have multiple implementation of the same. How we have multiple implementation? We write one interface and then we write multiple subclasses which is implementing this interface, right? And that way we can have different implementation of the same methods. Okay. The next point about polymorphism in Java is the point that I told you in the very first slide, that it refers to the ability of different classes to be treated as the instance of the same class through a common interface, allowing for flexibility and extensibility in our code. Now, how does that work? So let us say you have written one interface and we are writing multiple subclasses which are implementing this particular interface. So you can say that these subclasses are kind of instance of the same interface, right? That's what fourth point means. There are basically two types of polymorphism in Java, which we already discussed. Static polymorphism, that is compile time polymorphism, and dynamic polymorphism, that is runtime polymorphism in Java. So let us discuss static polymorphism in Java. So we already know static polymorphism is also known as compile time polymorphism in Java. That is the first point about static polymorphism in Java. That is, static polymorphism is also known as compile time polymorphism. And when does static polymorphism occurs? So static polymorphism occurs when the method calls are resolved at the compile time itself. What does that mean? It means when the decision about the method call is made at the compile time based on the method name and method argument that you are providing while calling the method, then it will be called as compile time polymorphism. Okay. And compile time polymorphism, how can we achieve compile time polymorphism? Compile time polymorphism can be achieved by method overloading in Java. Now let's have a look on a brief example that we have about static polymorphism in Java. Okay, so let us say we have a class calc, which is a short form of calculator, and we have written a method there called process data. and we are taking two argument, both are int, and the purpose of this method is to return addition of these two, that is a plus b. Now let us say we are trying to overload this process data method, okay, and this time we are taking three variables, or rather three method argument, int a, int b, and int c, and the purpose of this method is to return a plus b plus c. Now let us say we are trying to again overload this method process data, and this time we are taking double and int as a method parameter, and the purpose of this method is to return a minus b. So if you see, this process data method is overloaded in the calc class two times, okay, and in both the times, or rather the three methods written here, or one is the main method and two are overloaded method. These three are providing different behavior, but how we can say it is a compile time polymorphism? Rather, how we can say it is a static polymorphism? So if you see on the right hand side, I have written one main class, okay, which will contain main method, obviously, okay, and then what I'm doing, I'm creating the object of the calc class, and I'm trying to call the first method. If you see in the sysout, that is system.out.println print, I'm doing c dot process data 10 and 20. So if you see carefully here, c dot process data, c is the reference of the calc class, right? It is containing the object of calc. Now if you see c dot process data 10 and 20, so what it will do, compiler will, or rather JVM will check for a method process data in the calc class, which takes two argument, two int argument, right? So it will go here, it will try to find out a method called process data. It will try to check, or rather verify, the method parameter, okay. It will see int a and int b, which is two int parameters for a method name process data. So it will invoke this method process data and return a plus b. Now let us say I am trying to call this overloaded method in some way. Okay, so what will happen here? Let us say we are trying to call this method process data with 10, 20, and 30. That is three int variables, right? The method signature here is name of the method is process data, and it is taking three int argument. So what it will do? JVM will go to the class calc, because C is the reference of the calc class, and it will try to search for a method with the name process data. It will come here and try to search for the name process data, and then it will try to verify which process data method have three method argument. So we are providing three, right? 10, 20, and 30. So it will try to find out among these three methods which one is taking three argument, that is three int argument rather, okay. So it will find the second method, and it will try to call this method and return a plus b plus c, right? So that is how method overloading works. And if you try to invoke the third method, see, I have written C process data 20.0 and 10. 20.0 represents double. Why it represents double? Because so there are two basically floating point variables in Java. One is float and other is double. To write a floating point value as a float, you have to suffix that value with the f. Now since this is not suffixed with f, it is double, right? 20.0 is double here, and then 10 is the int value. So what it will do, it will go to the calc class and try to search for a method process data which takes two argument, double and int. It will come here and find this method, okay, and then it will return a minus b. Now let us see this example with the help of real coding. We'll go to STS and we'll try to explore this more there. To save the time, I have already written the code there. We'll just see the behavior there, okay. So let's go back to STS. So here on STS, if you can see, I have written the same calculator method, okay, and I have written the process data method here. So if you see here on the STS, I have written one calculator class, okay, and I have written process data method. It is taking two variables, int a and int b, and it is returning a plus b. I have overloaded this process data method, and now I am providing three variables, three method argument, right? That is int a, int b, and int c. And the purpose of this method is to return a plus b plus c. Okay. Now I am again overloading the same method with the different parameter. First one is double d, and the second one is int a. And the purpose of this method is to return d minus a. Now if you go back in the main method, I am creating the object of the calculator class, and I'm trying to call this method calc or process data 1020. It's a return 30, right? It will invoke this method, because when we do calc dot process data, calc is containing the object of calculator class. So it will go to the calculator class, try to find out a method with the name process data, which takes two argument, rather two int argument. So it will find the first method, and it will return a plus b. right? Now, coming to the line number 7, where we are calling the process data method, same method with the 3 argument. So what it will do? It will go to the calculator class, try to find out a method process data, which takes 3 argument, 3 int argument, right? So it will find this one and return a plus b plus c. Okay. And the same goes for the last method that we have here. Okay. Now, let us try to run this code and see the output. Okay. So run as Java application will bring this up. So if you see the first method you are calling 10 and 20, it's to return 30, right? It is returning 30. The second method you are trying to add 3 variables, 20 plus 10, 30 and 36, 60, right? So you are getting 60. The third method call where you are doing 20.0, that is a double value, and 10. And the purpose of third method is to return the subtraction of these two. And it is returning double value 20 minus 10, that is 10. You can see here, right? So if you see here in the code, the same process data method is actually returning different value, or rather behaving in a different way in a different situation, right? And this is actually what we call as a static polymorphism in Java. Okay. So if you see this code in the line number 6, JVM will already know at the compile time itself that it is calling this method because you have provided two variables here, 10 and 20. And there is only one method in the calculator class which takes two int variables, right? And the name, obviously, it will actually consider the name also. So with the process data name and int a and int b, it has just one method. So this method call, like which method is being called, is resolved at the compile time itself. That's why static polymorphism is also known as compile time polymorphism. And that's how it is behaving differently in a different situation here. Okay. So that's all about static polymorphism in Java. Let's go back to runtime polymorphism, or rather dynamic polymorphism in Java. So what is dynamic polymorphism in Java? Dynamic polymorphism in Java is also known as runtime polymorphism. Why it is known as runtime polymorphism? Because dynamic polymorphism occurs only when the decision about the method calls is made at the runtime based on the actual object present in the reference. What does that mean? It basically means, you remember I told you, in we write one superclass, or rather interface, and we write multiple implementing classes, and we assign the object of these implementing classes to the superclass, or rather interface. Okay, so based on the object that is available in that reference, we call the method. Methods are getting called, right? So that decision is being made at the runtime. That's why dynamic polymorphism is also known as runtime polymorphism in Java. Okay, so how do we achieve dynamic polymorphism in Java? I mean, what is the way by which we can achieve dynamic polymorphism in Java? So dynamic polymorphism in Java can be achieved by dynamic dispatch and method overriding. Okay, so let us see the first point about dynamic polymorphism in Java. I already told you it is known as runtime polymorphism. And the second point about dynamic polymorphism in Java is it is a behavior. If the behavior of the method is known at the runtime, then it is a dynamic polymorphism. That's what I told you. I told you that if the method calls are resolved at the runtime, then it will be a dynamic polymorphism. Okay. The third point about dynamic polymorphism in Java is it can be achieved by using dynamic dispatch and method overriding. What is dynamic dispatch in Java? The process of assigning subclasses object to the superclass reference is known as dynamic dispatch in Java. Okay. And on the method overriding, I'll make a separate video where I'll explain what is method overriding, because method overriding is a concept where there are a lot of rules to override a method. And we'll discuss all in the video where I will explain method overriding. Okay. So let's say we take an example. We write an interface, okay, animal, and it has a abstract method called void eat. Okay. And we write now multiple subclasses which will actually implement this interface and will try to override this eat method, and we'll see the behavior of the method. Now, let us say we are writing a class man that is implementing the interface animal, and it is trying to override this eat method. And we are trying to print only eating bread because man eat bread, right? Now, let us say we have a different class called cat, and it is also implementing animal. Cat usually eat rat, right? So the purpose of eat method here is to print eating rat. Okay. Now we are trying to implement we are trying to write another class which will implement the same interface animal, and here we'll try to override this eat method and we'll be actually printing eating meat for the lion, right? Now, on the right hand side, if you see, I have written main class, which will test the dynamic polymorphism. And here I will write a main method, okay? And we'll just assign the animal A, okay? Because animal is an interface, we cannot create object of the interface directly. So what we do in the next line, we'll try to assign the object of man class to the animal. And this process of assigning the subclass's object to the superclass or rather super interface will be called as dynamic dispatch in Java. You can see on the right hand side of the method of the object assignment, I have written DD, which simply means it is dynamic dispatch in Java. Now let us say we are trying to call this eat method with reference A. Which method it will call? First, it will go to the interface A animal and it will try to find out a method called eat. It will find one, right? Because we already have one eat method in the animal. Now it will check which object of subclass we have in the at this reference A. So it will find out that it has a man reference, right? Man object of the man. So it will go to the man class and try to find the overridden method that is eat, and it will print eating bread. Okay, and then same goes for the cat and lion. Okay, and it will print eating rat and eating meat. Okay, now let's go back to STS and we'll try to explore the same with the help of coding to understand this concept of dynamic polymorphism in Java in a better way. So to save the time, I have already written the code to make you understand in a better way. So here you can see, as I explained in the slide, I have written one interface called animal, okay, which has a abstract method eat. What is abstract method actually? Abstract method is a method which doesn't have any body. Okay, so you can see just the method signature here. This is the modifier, this is the return type, and this is the name of the method. Okay, so here you can see we have an interface animal and we have a eat method there. Okay, now we will write a class man which will actually implement the interface animal and will try to override this eat method, and in the overridden method we are trying to print eating bread. Okay, same goes for the cat class. We have written a class cat which is implementing the animal method, and in the overridden method cat we are trying to print eating rat. Okay, and same goes for the line class where we are trying to implement line class is implementing animal method, and in the overridden method eat, what we are doing, we are trying to print eating meat. Now to run this code, I have already written a main class which is containing main method. Obviously the name of this class is dynamic polymorphism demo, and we have a main method. We have just taken a reference of animal A here in the line number 5. Now in the line number 6 we are assigning this reference to the man object. Okay, and then we are trying to call this eat method. So it will be going to the animal interface trying to find out method eat. Okay, since this method is abstract, so it will try to find out which object is there in the reference A. So it will find out it is a man reference. So it will go to the man class and try to find out the overridden method eat, and it will find one and it will try to print eating bread. Same goes for the cat and lion. Okay, what it should be printing? It should be printing eating bread first and then eating rat for the cat and eating meat for the lion. Okay, let us try to run this code to see how it behaves. Okay, so you can see it is first invoking eating bread method, which is a overridden method in man class. Okay, second it is printing eating rat, which is basically overridden method in cat class, and third it is printing eating meat, which is basically overridden method in lion class. Okay, so if you see here in line number 5 there is an interface animal A. Okay, and there is in line number 7 you can see a dot eat. So at the compile time JVM doesn't know which method is being called in line number 7 or line number 9 or line number 11, because this method will be invoked based on the object that is available in the animal reference, right? So if it is a man reference, it will call the method overridden method eat available in the man class. If it is a cat object available in the reference A, then it will call the method available in the cat class. If it is a line reference, it will call the method available in the line class, right? So these method calls are not being resolved at the compile time. It is being resolved at the runtime. That's why dynamic polymorphism is also known as runtime polymorphism in Java. Okay, so that's all about dynamic polymorphism in Java, or rather polymorphism in Java. So that's all for today. If you want the code and the notes shown in this video, please do comment your email ID and you will get this within 24 hours. Also, I'll be posting more such informative video on this channel. So if you found this video helpful, please do like, share and subscribe. Thank you. Bye bye. Take care.